In chemistry, we talk about numbers and we talk about significant figures. And that's because in chemistry, we are concerned with both being accurate and with being precise. This is also an issue in industry. In industry, especially if you're in the medical community, you want to be giving chemicals to people that are the accurate amount. You want to make sure that people who are delivering them are consistent or precise in how they're giving the shots and how much they are filling the shots. So these are things that are important and they matter. Accurate measurements agree with a standard. And then you're going to say, well, how do you get the standard? Well, you get the standard from having a lot of precise measurements. But in industry and in situations like that, the standard comes from usually someone in the federal government or something like that will do several studies and find out what amount is basically the safe amount. And that will become the standard. You can't go past that amount. In chemistry, when we report things in journals and things that get published, we need to make sure that we are giving as precise measurements as we can, as well as accurate measurements. So we're going to make sure all of our equipment is all calibrated correctly, but we're going to be precise. And precise are measurements that agree with each other. This is why when people do experiments, they do them over and over. They usually do them several times because they want to make sure that it's reproducible. And if you report it, someone else can make it. If you report something and no one else can follow the experiment or repeat it, then your article will get retracted. So how does this matter with Sig Figs? Well, we're going to look at this ruler right here. I know I didn't put anything for percent error, so let me say that really quick. So for percent error, you have some kind of, we call it true value, but it's that standard. It's whatever they tell you the standard is, minus your experimental value. And these are absolute values. So it means like you can just subtract them however you want. If you get a negative number, just make it a positive number. Over your true value times 100%. You'll see this in lab. You're going to get to use that over and over and over. It tells us how close our experiment was to the to what you should have gotten. So if someone's really, really good at that experiment, we know the number and what it should have been. And then if this is your first time doing it, you would expect it to be a little bit off. Percent error is best when it's very low. That means you are close to what the standard is. But let's look at the precise measurements. These are ones that agree with each other. And so precise measurements mean that when you look at a ruler, like this one right here, and you're trying to decide which ruler will be the better ruler to measure this object. So these are the exact same objects. It's been copy and pasted. If you look at it, you can probably tell that one ruler has a lot more markings on it. So obviously you're going to say, oh, the one with more markings is going to be the better ruler. But why is that better? Well, it's because if you have a whole classroom and you give them the top ruler right here, the best that they can do is they can say that it's somewhere between, let's see, this is 3/4. So this would be like 7/8. And so they'll say it's somewhere between 7/8 and 1. And they'll make some kind of a guess on where it is in that range. If you give everyone in the class the lower ruler, they can get a lot more specific. They can say, oh, well, that's somewhere between, this is in 30 seconds, so this would be 31 over 30 seconds, and this would be 30 over 30 seconds. You can reduce that, but they'll say, well, it's between those two numbers. So everyone in the class would get more consistent numbers using this lower ruler. In terms of Sig Figs, the reason we care is because when we tell someone we have a number like this, we're telling someone we measured it with a ruler that could measure to the thousandth place. If we just are reporting numbers like that, then our ruler or our scale or whatever equipment we had could only measure to the tenths. So that's why sig figs matter, is because they aren't just telling us something about numbers, but they're telling the reader and the person who's trying to follow the article, they're telling them basically how sure they are of their numbers. They're sure all the way over to this decimal place. And we do have equipment that will measure much further than the thousandths place. As a little pro tip, though, it gets more expensive and more and more and more expensive. So we would say that it's the second ruler. And when you're trying to keep them straight, because the words kind of sometimes in our language get used interchangeably. So the A in accurate, that's what I remember. So accurate is like making an A, hitting the target in the center. And then I remember that precision is the other one. So you can tell they hit the target here 3 times, so they are accurate. Let's see if we can find another place they hit the target. They did not hit it here. They did hit it here, so that one's accurate. And if we go over to the right, no, there aren't any accurates. And then we're going to check out the precise. So precise is when your measurements are agreeing with each other. So you look here, this one is precise. They're agreeing. And it'd be nice if these were just a little bit closer, but like compared to over here, we're going to say that these were close enough. And we'll say that that's precise. Over here, we have a here and here and here, so that's not precise. And then this is also not precise. They're really far apart. So this is neither of them. This is accurate and not precise. This is precise and not accurate. And then this is both. So if we put in a real life chemical context, if you imagine a nurse giving 3 shots, they're supposed to be 5.0 cc's. So maybe that's because that's the, what the FDA says. It has to be exactly 5.0 cc's. So she's drawing them out, and maybe the one is this number, and this number. Well, these are pretty close numbers, and so just for the point of emphasizing, we're going to say that she was accurate and precise. But I just wanted to note that it depends on the industry that you're in as to how close numbers have to be if they're precise. So in this case, if the FDA said that it was within, that being within 1/10 is okay for it being considered precise, well, that's the number you follow. A baseball player strikes out every time he hits a pop fly because it goes the same left fielder. Okay, so if the goal, we're going to assume the goal is to get a home run. He's not getting that, so he is not making his A, so he's not accurate. But every time he hits a pop fly, he is precise. And I'm going to leave this one here for you to do. So go ahead and fill this in before the next video. And you'll notice this has, right here, it's delivered with this kind of a dispenser. So this is the true value right here. That's the true value, or the standard.